In lesson 2, we are going to have an introduction to vectors, what they are, and the various properties of vectors. So what is a vector? So if we're distinguishing between scalar and vector, a scalar quantity indicates that it has a magnitude or size only. It does not include a direction. So some examples might be temperature, or distance, or mass. A vector quantity, or a vector, is a mathematical quantity that has both magnitude and also has a direction. So for example, velocity might be described as 80 kilometers per hour in the westerly direction, or we might have a force where we are pulling down by a force of 10 newtons. So here are a few quantities, and we want to determine which ones are scalars and which one are vectors. So I will put the scalar, let's do the scalar in red, and we'll do the vectors in blue. So if we look at scalars, quantities that only have one value in terms of magnitude or size might be something like length is a scalar. Distance is scalar. We might have area, only has one quantity. Time is scalar. Volume is scalar. And energy is scalar. Density is scalar. So these are values that only have a magnitude and not direction. You might look at mass is scalar. So there's a difference between mass and weight. Weight is a vector because it has a mass in a certain direction. So that is the definition of weight. It's the same with speed. Speed is a scalar quantity, but velocity is a vector quantity because it is speed in a specific direction. Other vectors might be work. We are indicating not only the magnitude of the work, but the direction that the work is being applied. Acceleration is a vector. Lift indicates what direction. Displacement obviously has a direction. Drag has a direction. Thrust has a direction. So those are vector quantities, and then we'll just round it out. Temperature would be scalar. Pressure would be scalar. Power would be scalar, and we've got one more here, force. Force is a vector. So those are just the various types of measurements, and differentiating between whether they are scalar, where it's just magnitude, or vector, where it has magnitude and a direction. So how do we represent vectors? So vectors are represented with a line segment. So it is a directed line segment. It has a length, which is called its magnitude, or a size, you might say size, and a direction, which is indicated by an arrowhead. So it's going to look something like this. I've got a length, and then I've got an arrow that indicates the direction in which that vector is going. So here we have an example of vector A to B. So we could name it in two different ways. We could say AB, and you'll notice that there's an arrow on top indicating it's a vector. So A would be the starting point, and B would be the ending point. And that is important because that would be different than B to A, which would start at B and end at A. So direction matters. The way you write the letters matter. You could also describe it by a single letter. So in this case, we use vector V, and you'll notice again it has that arrow on top indicating it's a vector. If we're talking about just the length or size or magnitude of the vector, we show absolute value brackets around the vector. So AB is a vector, whereas if I put absolute value symbols around this, then this is the magnitude of the vector. So I'm looking at the length or the size of that vector. And of course, absolute value is always positive, so the magnitude is always a non-negative number. Okay, direction. Let's talk about direction. Direction can be represented in a few different ways. One way is to measure it from the horizontal. So when we talk about the horizontal, we're talking about the positive x-axis and measuring in the counterclockwise way. So here, let's see if we can make this larger. Here I have a diagram. It is being measured from the horizontal. I can see that line here, and I can see that the arrow is going counterclockwise 110 degrees. So if I were describing this vector, I would say it is a 14 centimeter vector at 110 degrees to the horizontal. So that indicates that I'm starting at the horizontal and going counterclockwise. If I were to draw 5 kilometers at 30 degrees to the horizontal, I would draw my horizontal. I would measure from there at counterclockwise 30 degrees. So I'm going in the counterclockwise direction, and it is 5 kilometers, so I would label that on the vector 5 kilometers. Another way to indicate direction of a vector is a true bearing. So a true bearing starts at north and goes clockwise. So here we have another diagram. So I can make this bigger. So if we look at the north, south, east, west diagram, the true bearing starts at north, goes in the clockwise direction. So I can see that this diagram, here's north. The red line is the end result or the resultant, and I can see the arrow going in the clockwise direction, and it is going 135 degrees. So I would say the true bearing is 135 degrees. Okay, when I write it like that, that is assuming it is from north. Actually, I didn't put let's put the magnitude. I missed that. So the magnitude is 2.3 kilometers. At a true, I might put at a true bearing, just to indicate I'm starting at north. At a true bearing of 135 degrees. So if I wanted to draw the diagram of 2 kilometers at a true bearing of 060, so we always use 3 numbers. So if there's a 0, that really means 60 degrees. So I would draw my north, south quadrants. I would go 60 degrees from north, which would be in quadrant 1 here. And I'll label that as 60. And then I will put the length or the magnitude of that vector as 2 kilometers. A third way to describe bearing or direction is a quadrant bearing. So a quadrant bearing always starts at the north-south line and either goes east or west. So your description will always start with either N or S, north or south, and then it will either go east or west. So in this diagram, the red line is the resultant. So I can see that it is in quadrant 3. So it is starting at south and it is headed towards the west. So this vector is starting at south and going towards the west, 35 degrees. And that magnitude, it's hard to read here, 98. I think it says 98 newtons. Okay, so if I'm describing this, this is 98 newtons. And the quadrant bearing would be starting at south. I am going 35 degrees towards the west. So you'll notice that we put square brackets around that to indicate the true bearing. In this one, we have a description of 25 kilometers at a quadrant bearing of north 80 west. So I want to draw this diagram. So I'm going to do my north, south, east, west, and I'm starting at north and I'm headed towards the west. So I'm starting at north and I'm headed in the westerly direction, 80 degrees. So that would probably put me round about there. So this is 80 degrees and it is a 25 kilometer per hour vector or magnitude. Okay. So here we have an example. It wants you to convert a true bearing of 150 to a quadrant bearing. So I'm going to draw a true bearing of 150. So that would be starting at north, going in the clockwise direction. So we've got 90, 150 would be approximately here. So there's my resultant. So this is 150 degrees. Now remember, we always measure from either north or south. So the resultant is closer to the south than the north. So I'm going to start at south and I will be headed, I didn't put this on here, east and west. So this resultant is starting at south and is headed towards the east. So I need to determine that quantity there between the south and the resultant. I know it's 150 to the resultant from north, and I know south is 180. So if I do 180 minus 150, I will get that bearing of 30 degrees. And so this can be described as starting at south, I'm headed 30 degrees towards the east. In this question, we want to change a quadrant bearing to a true bearing. So again, we're going to draw a diagram. So we'll label north, south, east, and west. It starts at north and it goes 50 towards the west. So I'm going to go this way, 50 degrees in the westerly direction. So there's my resultant. Now remember that in true bearing we start at north and go clockwise, so I have to start at north and go all the way around to here. So as a true bearing, I would be 50 degrees, so remember that it would be 360 to go all the way around. So if I do 360 minus the 50 degrees, I will get a value of 310. So if I go north 50 to the west, it's the same as starting at north and going clockwise all the way around 310 degrees.